Okay, problem number 1 says, how many liters of 0.5 molar calcium hydroxide would you need in order to have 5.5 moles of calcium hydroxide? Well, here we go. Let's see if we've got, oh, that's a fancy pen. If we've got 1 liter, then we have 0.5 moles. So if we wanted to have 5.5 moles of calcium hydroxide, we would need times 11, which would mean we need 11 liters of CaOH2. Find the number of moles of sulfuric acid needed to react with 5.5 moles of calcium hydroxide. Well, we need our balanced reaction first. So let's see, we've got H2SO4 plus calcium hydroxide is CaOH2. And that forms HOH, and looks like there's 2 on both here and here, so that means we need a 2 there. Kind of getting ahead of myself a little bit, but and then Ca is a +2 and SO4 is a -2, so we got CaSO4. So if we add 5.5 of these, then we need 5.5 of these. And then it says if the sulfuric acid has a concentration of 0.82, how many liters are needed to react with 5.5 moles of calcium hydroxide? And we know that this is 0.82 moles of H2SO4 in 1 liter. And we need 5.5 moles. So 0.82 times 6, 7, somewhere in the neighborhood is 6 or 7, somewhere between 6 and 7. Let's say 6.8. So we need about 6.8 liters. Go back here. Problem number 2 says calcium carbonate reacts with hydrochloric acid. And it says what mass of calcium carbonate is needed to make 1.2 liters of 1.7 molar. Okay, so we're going to make, if we got 1 liter, that means we got 1.7 moles. And we got 1.2 liters, which means that we've got 1.7 plus 0.17, plus 0.17, which would be 0.34. So that would be 2.04 moles of CaCO3, and Ca is 40 plus C is 12 plus 48 for the is 88. That's 100. So we need, that's 100 grams per mole. So we would need 204 grams of CaCO3. Okay. What volume of 3 molar HCl is required to completely react with the amount of CaCO3 in part 2A? All right, well, let's take a look. We've got 3 molar HCl, and we know we need the balanced reaction first. So we've got CaCO3 plus HCl, and that gives us H2CO3 plus CaCl2. And we need a 2 there. I think that's it. So we know that this was 2.04 moles, which means this is going to be 4.08 moles. And if we've got 3 molar, that means there's 3 moles in 1 liter. We've got about 4 moles, which means we're going to multiply by 4 over 3, which means we need about 1.33 liters. How many moles of carbonic acid would be produced? Well, carbonic acid is right there. So we're going to do Okay, and the last part of this, numbers 3 and 4, ammonium chloride and calcium hydroxide react together. So let me go ahead and pop that up. So we've got NH4Cl and CaOH2 goes to NH4OH plus CaCl2. So we need 2 there, 2 there. I think we're in good shape now. We got 2 NH4s, 2 NH4s, 2 Cls, 2 Cls, 2 OHs, 2 OHs. Okay. What mass of ammonium chloride is needed to make 1 liter of 2 molar? Well, if we have 1 liter, we have 2 moles. So we would need ammonium chloride is NH4Cl. That's this one right here. So we've got 14 plus 4 plus 35 and a half. 53 and a half grams per mole. And we need 2 moles, so that would be 107 grams of NH4Cl. What mass of calcium hydroxide is needed to make 2 liters of 2 molar calcium hydroxide? Okay, well, again, there's 1 liter, and we want to make, and we know that it's 2 molar, so we're going to make 2 liters. And so that means there's 4 moles of CaOH2. And the molar mass is 74 grams per mole. So we would need 4 moles, we said. So that's 7 times 4 is 280, 296 of CaOH2. How many grams of calcium chloride will be made when 1 liter of 1 molar calcium hydroxide reacts with excess ammonium chloride? So we're looking at we don't need that one, and grams of calcium, so we're looking at those 2, which are a 1-to-1. There's 1 CaCaOH2 to 1 mole of CaCl2. So it's 1 liter, 1 molar, so that means we need 1 mole of CaOH2, and that means we'll get 1 mole of CaCl2, so it's just the molar mass of that. So that's 40 plus 71 is 111 grams of CaCl2. Zinc and hydrochloric acid react together. That's Zn plus HCl. And that gets me ZnCl2 and H2. I need a 2 there. That's 1 to 2 to 1 to 1. What volume of 0.1 molar will react with 26 grams of zinc? Okay, so 26 grams of zinc. Alexa, what's the molar mass of zinc?
Zinc's atomic mass is 65.38 unified atomic mass units.
65.38, so 65.4 grams of zinc per mole of zinc. And so we've got 52, so that would be about 52, we got 13. So 52, that would be 2.5 moles. 2.5 moles of this that we're starting with, and we're looking for HCl, so this is going to be twice as many because of the 1-to-2 ratio. So we got 5 moles of HCl. Ooh, we need a lot of this stuff. So this is 0.1 moles, and we got 1 liter, and we need 5 moles. That means we've got to multiply by 50, which means we need 50 liters of HCl. That's a lot. Then the reason that it's a lot is because this stuff is pretty weak. We only got 0.1 moles in 1 whole liter. That's a lot. I mean, that's a very weak concentration. Mass of zinc with 2 liters of 0.25. So if this is 0.25 moles of HCl per 1 liter, then in 2 liters, we've got 0.5 moles. So go back to the original equation. If there's a 1-to-2 ratio, there's 1 zinc to 2 HCl's, and this is 0.5, then this is 0.25 moles. And Alexa just told us that this is 65.4, so that's going to be half of that would be 32.5 Half of that would be 16 1/4, so about 16 grams of zinc. How many liters of hydrogen, that's this one up here, will you make at standard temperature and pressure if you react 2.74 liters of 0.45 molar HCl with excess zinc? So, again, 0.45 moles of HCl in 1 liter. We've got 2.74 liters. I don't know who made this problem, but 2.74 liters. Let's just call it 2 3/4. So we're going to multiply this by 2 3/4. 0.45 times 2 would be 0.9. And 3/4 of 0.45 is about, let's call it 0.3. So that's 1.2 moles of HCl. And if that's 1.2 moles of HCl and it's a 2-to-1 ratio, then that means that we've got half of that, which is 0.6 moles of H2. And this one is standard temperature and pressure, so that means that there's 22.4 liters to 1 mole. And the reason that we can use that 22.4 is because hydrogen is most definitely a gas. So 22.4 times 0.6 is 20 times 6 times 0.6 would be 12. Plus another 2 times is 1.2. And then 0.4 would be 0.24. So we've got about 30.